supervolcano threat, early warning system is needed in face of devastating risk, according to what one expert claims. We know that there are about 21 supervolcanoes, if not more, around the Earth. The latest super eruption occurred in the North Island of New Zealand, Mount Taupo, a super eruption that left a lot of disaster. Anthropologists claim that only 2,000 couples of humans were left to repopulate the Earth. It was an extinction level event. Now, an early warning system, he says here, is needed to alter the world to implementing supervolcano eruptions, the volcanologist said. George Cooper, research associate at the School of Earth and Environmental Sciences at Cardiff University, warned Yellowstone and other active volcanic systems had the potential to cause devastation on a worldwide scale. In case of a super eruption, of course, he said the impact could be lessened by a better understanding of the process at work. Cooper set out his findings in a report which he co-authored last month and which was published in Nature Review, Earth and Environmental last month. He concluded that there is no single model which can describe how such catastrophic events play out, making it extremely difficult to determine how supervolcanoes may erupt in the future. Cooper said forecasting an imminent eruption would make a difference, although it would be a huge operation to evacuate people from the area, and a real challenge is in knowing how much magma will be erupting and how long it will last. For example, some super eruptions lasted for only a few days, whereas others lasted perhaps for decades, which has very different implications for hazard management, of course. Kindly support my Patreon account since YouTube has again demonetized my YouTube channel. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. He said the ignimbrite deposits from concentrated ground-hugging pyroclastic flows, typically meters to 100 meters thick, in other words, as high as mountains, from a super eruption can cover areas of thousands to tens of thousands of square kilometers. Now, he says it is within this area that devastating destruction would occur. Beyond that, ashfall from the eruption would extend further away and may change global weather systems and climate in the short term. He says, however, it's important to note that the super eruptions are part of a suite of eruption styles from these volcanoes, and that smaller eruptions can occur, which are really important to know about, as we could effectively mitigate their impact much better. So we should keep monitoring these systems. Supervolcanoes are defined as a volcano that has had at least one explosion of magnitude 8, the highest ranking of the Volcanic Explosivity Index, or VEI, meaning it has released more than 1,000 cubic kilometers of material. Such a super eruption would have a global impact in terms of weather and climate change, Cooper says. He says we can look at the example from Eyjafjallajökull eruption in 2010. That's an area on the eastern shore of Iceland. That volcano that erupted in 2010, has an impact that a small volume ash-rich eruption could have on transport and supplies. We would expect larger impacts on aviation in a super eruptive event and the associated challenges that would bring. He says, however, as we are not close to any large silicic system in the UK, the volcano hazard, ashfall, pyroclastic flows, etc., do not pose a direct threat to life within the UK itself. It's the subsequent consequences that would be challenging for UK-based people, he says. Cooper also stressed that in many ways, the very term supervolcano was an oversimplification. He says it's important to understand volcanic activity at all scales, not just the largest events. What we highlight is that the largest systems in the Quaternary, that is the last 2.6 million years, all operated differently. And as a result, there was not one specific way to generate supersized eruptions, he says. He explains this is important information as it means that forecasting when the next eruption of this scale may occur will be difficult, as there is not one set of warning signs that can be monitored, and these volcanoes have the potential to produce small-sized eruptions as well as large eruptions. He says the fact that these systems are so diverse highlights the importance of developing familiarity with individual systems and having experts working with advanced monitoring systems in place at all of these locations. Such work was already underway in many places, for instance by Yellowstone Volcano Observatory in California, GNS in New Zealand, and Sirga Geomin in Chile, he said. He said one particular important aspect that we can study is the timescales involved in the magmatic processes that lead up to these eruptions. For example, movement of large volumes of molten rock under the surface. We find that the information, he says, of eruptible magma bodies beneath the surface may take anywhere from tens of thousands of years to only centuries. If we are to monitor these systems in the future, to have any kind of early warning system on place, then this information is crucial. Cooper said one common misconception was that the Earth was due, quote unquote, an eruption. He says these systems do not have a periodic interval over which eruptions happen. To imagine blowing up a balloon with magma until it bursts is very much an oversimplification of the complex interactions between crustal stresses which eventually allow magma to ascend. Geophysical evidence suggests several modern systems, for example, Yellowstone, Toba in Indonesia, and Laguna del Maule in Chile, have moderate amounts between 5 and 15% of magma, also known as melt, underneath them, and such systems were active, therefore, but additional processes would need to happen before the systems could erupt, Cooper said. Detailed geological surveys could measure changes in the percentage of melt, which in turn would offer vital clues about how the systems vary over decades and centuries. This is by Express UK, Kieran McGrath. Please leave your comments and thank you for your support.